Hello everybody. In this video, we'll go over two more examples for hypothesis testing. We look at left and right and left-tailed examples. So we're told that the administrator at a local hospital, states that on weekends, the average wait time for emergency room visits is 10 minutes. So the average wait time is 10 minutes. Based on discussions you've had with friends who have complained on how long they've waited to be seen in the ER, you dispute the administrator's claim. You decide to test your own hypothesis. Over the course of a few weekends, you record the wait time for 40 randomly selected patients. The average wait time for these 40 is 11 minutes with a standard deviation of 3 minutes. Now, do you have enough evidence to support your hypothesis that the average ER wait time exceeds 10 minutes? You opt to conduct the test at a 5% level of significance. Let's solve this question. Now, this question has actually made things easier for us by saying that directly asking, do we have enough evidence to support your hypothesis that the average wait time is greater than 10 minutes? So your hypothesis here refers to the researcher's hypothesis, and generally the researcher's hypothesis is the alternate hypothesis. And the status quo is our null hypothesis. So this makes it easier for us to write down our story. So we're told that on average, the population average, at least according to the hospital, is that mu is equal to 10. The wait time is 10 minutes. But you as the researcher, you're contesting that no, mu is not equal to 10 minutes, but it should be actually more. It has to be greater than 10 minutes because you're contesting the null hypothesis and your alternative is that mu is greater than 10. Now, you've conducted a sample of 40 patients and you have an X bar of 11 minutes and a standard deviation of 3 minutes. Now, we have to go and check if we have enough evidence to either reject the null or not, or if we don't have the evidence to reject the null. So we've set up our hypotheses. Our sample size is greater than 30, so we can comfortably use the central limit theorem without any worry. So the first step is all set. Second is to decide on alpha, and the question tells us we should conduct this test at a 5% level of significance. So alpha is 0.05. Let's go ahead and compute our T star. X bar was 11, mu naught is 10, S is equal to 3 over root of 40. So essentially we have 1 by 3 over root of 40. So this is pretty much root 40 by 3. And if I take my calculator to compute this, square root of 40 divided by 3 is about 2.108. So this is my T star. Now, in the next step, we have to identify our rejection region. Now, let me graph out the rejection region and we'll figure out how to compute our critical values. So if this is my T distribution, and if I have 0 here, this is a right-tailed test. So I'm going to be interested in this region. And I want to identify the region such that the probability of finding an outcome in that region is 5% or lower. So my cutoff will be here. And I'll choose T alpha with n-1 degrees of freedom in such a way that this area to the right is equal to alpha. Here it is 0.05. And all I have to do is identify that cutoff point, and that will be my critical value. So T critical value is just T alpha with n-1 degrees of freedom, so that the area to the right of that point is 0.05. Now alpha we know is 0.05, n is 40, therefore n-1 is 39. So if I were to compute this, so this is nothing but T crit, CRIT. So this is T 0.05 and 39. Let's compute that value. Let me actually use a different color for this. So let me use purple. Now I'll go to my applet and check. So our degrees of freedom are now 39. And I want my area to the right of a particular point to be 0.05. And what is that point? So this point here is 1.685. And area to the right of 1.685 is 5%. And there we go, there we have our critical value. So let's go back to our notes. So the critical point is 1.685. So this point is 1.685. Now our t statistic was 2.108. T star lies here. This is T star, which is equal to 2.108. Now the T star of 2.108 lies in the rejection region. So what was the rejection region? This is our rejection region. Okay, so this is the rejection region. And therefore, we go ahead and reject the null at 5% level of significance. Let's compute and check if we're getting the same result using the p-value approach. Well, the p-value is the likelihood of, so if we have our t statistic here, so this is our t star, which is 2.108. So the p-value is the likelihood of obtaining a value that is equal to t08 or more. So this area is our p-value. Remember, we are only doing a one-page test. So p-value is probability of t being greater than or equal to t star. And we can very easily compute this from our applet. So if I go into the applet, my apologies. Yeah, so if we go to the applet, yeah. So here I want the area to the right of the point 2.108, and the answer is 0.02075. So we'll come back here. So this area is 0.02075. 0.02075. Now the p-value is 0.02075. Alpha is 0.05. Now p-value is lesser than alpha, therefore we reject our null hypothesis. So how do we make sure that's the answer? Well, our t critical value is here. So this is 1.685, and the area to the right of this point, this area is 0.05, and we are seeing a p-value that is lesser than our threshold. So anything that has a probability value less than 5%, we're going to reject that. And we see that the likelihood of obtaining a value greater than or equal to t star, which is our p-value, is extremely small. It's about 0.02%. And therefore, it's an extremely unlikely event. So we go ahead and reject our null at 5% level of significance. And that's how we solve this question. I'll follow up with another example where, actually, I'll just continue in the same video and do a second example. Okay. A restaurant advertises that its burritos weigh 250 grams. A consumer advocacy group doubts this claim, and so somebody is doubting a claim, and they obtain a random sample of 24 of these burritos to test if the mean weight is significantly lower than 250 grams. They calculate a sample mean weight, and a sample standard deviation is given to us. Now, the advocacy group wants to use the sample data to do a t-test on the mean. Conduct this test at a 5% level of significance. Okay, so let's unpack this. Now, again, this question clearly helps us out write down the alternative hypothesis, because assume that you are the consumer advocacy group and you're doubting a particular claim and you're looking for evidence to support a particular perspective, that because you want to test that the mean weight is less than 250, whereas the restaurant is saying that the mean is equal to 250. So whatever conclusion we want to find, that will generally be the alternative hypothesis. So the alternative is that mu is lesser than 250 grams. And the null will be the opposite of that. So here, we're told that the restaurant advertises that its burritos weigh 250 grams. So we'll take that to be our null hypothesis. So here we have a left tail test. So, and we're also told that X bar is 242, S is 12, and N is equal to 24. So we've set up the hypotheses. Here, of course, we can use the central limit theorem comfortably if the sample size is greater than 30. But as long as the underlying population distribution doesn't have any significant outliers, we can still use the central limit theorem. So let's not worry about this condition for now. So let's not worry about it for now. So I'm just going to remove this. We'll just go ahead with our usual way of testing the hypothesis. Now, the next step is to decide alpha. Alpha is 0.05 here. The question tells us that. Compute the test statistic. Well, it is 242 minus 250 divided by 12 by root 24. So that will be minus 8 divided by 12 over root 24. So let's go ahead and check that. 8 divided by 12 divided by root 24. The answer is minus 3.266. So that is our T star. So we've identified our test statistic. Then in the rejection region approach, we have to calculate our critical value. So let's draw and identify the rejection region first. Let me use a different color. So that is my T distribution. So we have 0 here. And my test statistic. So, okay. And because I'm doing a left tail test, I'm going to be interested in this part of the distribution, the left of the center. And I'm going to identify the region such that the probability of values falling in that region is 5% or lower. So I'll choose a cutoff such that this area is equal to alpha or 0.05. And this will be my rejection region. So we have to identify minus T alpha n minus 1 degrees of freedom. So alpha is 0.05, n is 24, n minus 1 is 23. So let's go to our applet and identify what our critical value is. So let me specify the degrees of freedom, it is 23. And this time I'm going to say the area lesser than a particular number should be 0.05. And when I do that, I identify this particular value, and this turns out to be minus 1.7. So let's go back to our notepad. So this number is minus 1.7. So the critical value is, it is actually T minus T alpha n minus 1 degrees of freedom. It is minus 1.7. Now that's the critical threshold. And our T star is minus 3.266 or minus, so it's going to be somewhere here, minus 3.27. That's our T star. Now T star falls in the rejection region. Falls in the rejection region. Therefore, reject H0 at 5% level of significance. So compute T stat, compute the rejection region, check if your T star falls in the rejection region. If yes, reject it. If we were to use the p-value approach, well, we only have to look for finding a value more extreme than our T star. Okay, so our T star is here, minus 3.27. Okay, this is T star. My p-value is this region where it's the probability of finding a value more extreme than T star. With more extreme here means more negative. And it's a one-tailed test, so I'll only focus on the left tail because it's a left tail test. So the p-value is actually the probability that p is lesser than or equal to p star. P is, probability of area being lesser than minus 3.27. So let's go to our applet and check what this is. So for the same degrees of freedom, I am going to specify minus 3.27 here. And look for the area to the left of that point. Well, it's so tiny that you can't even identify it on the map, on the graph, but this answer is 0.00168. That's our p-value. So let's come back. So this area is 0.00168. So the p-value is 0.00168, alpha is 0.05. Clearly, p-value is lesser than alpha. And how can we be sure about that? Well, alpha comes somewhere here. Okay, so this is minus 1.7, and all of this region is alpha. And clearly, my p-value is just a small fraction of that alpha. And when p-value is lesser than alpha, what we do is we reject our null hypothesis at alpha is equal to 5% level of significance. And that's how you compute and run a simple hypothesis test on a single sample mean. We've done this, we've looked at these solutions using the applet. I'll also upload an Excel file and an R script where I walk you through these calculations, where I do these calculations. So please feel free to check out those files if you want to know how to do this in R and Excel. So that broadly wraps up hypothesis testing. There's one more small section, which I'll post a video about. So I'll see you in that one.